Thanks for tuning in. This video is about migrating a legacy application from an on-premise environment to the Azure cloud. In the process, we will modernize the app to leverage on cloud scalability and service-based reusability.
The scalability part of moving to the cloud is obvious. When we move an application to the cloud, it can immediately benefit from leveraging on the elastic scalability of each of these components. The less obvious part is actually in leveraging the service-based nature of cloud-based components. So take, for example, Key Vault over here. Imagine having to manage your own secret management software on-premise. Not only do you have to buy the software, you have to maintain the software. Your IT organization will also have to manage the security of the environment in an enhanced way around your secret management software. So all of this adds additional work and stress to your organization that may not be directly related to your business. If it's not done well, it may even lead to bad practices around security, or even worse, because it is so complex, it might just lead to people avoiding it altogether and take a bootstrap approach, and that will lead to security vulnerability. So all of this can be avoided by leveraging on cloud services. So secret management is just an API call away. API management is just an API call away. So when everything is an API call away, it makes things easier to manage and less costly to integrate. So that's the benefit of service-based cloud applications. This video is based on the Microsoft Cloud Workshop at Modernization Hands-on Lab. Besides going through this video, I highly recommend you go through the exercises that are available in this hands-on lab step-by-step guide as well. I will post the link to this repository along with the video. The first task is to create a resource group. So we'll click here, add, and give it a name. So hands-on lab. I'm going to choose Southeast Asia. And that's it. So we'll create the resource group. The second step is to make sure that your subscription has the Microsoft data migration and Microsoft Search resource provider registered. So let's look at our subscription. And this is the one that I want to use. And look at resource providers over here. So look for Microsoft data migration. As you can see, it's already registered. If it's not, please do register it. And we'll look for Microsoft Search, which is also registered. So if it's not registered in your case, this will be a link, and you can just simply click on register and register the provider. So the next thing that we are going to look at is the deployment of the resources involved in the hands-on lab itself. So for this, we need to go back to the documentation here. So within the docs, on task tree, you can find this button. So if you were to click on it, it brings you back to your Azure portal. So these are all already filled out, right? So the only portion to change is to select the resource group we want to use, which is the hands-on lab, and you want to give it a API management email, which is your email. So yeah, that's it. We'll wait for some time and we can start the next section when the resources are ready. Before we embark on the exercises, let's take a look at the context. Here's a few customer situations. Contoso provides a full range of long-term insurance to help underinsured people. They are trying to cope with being overloaded due to faster than expected growth. So Contoso has created a custom Windows Form app called Policy Connect for their employees to manage policyholder information. Their data is stored in a SQL Server 2008 database and a file server on their local area network. So entirely on-premise. This is a high-level look of the architecture. Contoso's employees rely on email as a workflow engine for document management tasks. They would like options to gain insights without requiring custom development time. They want to make policyholder system available through web and mobile applications without VPN. Here's a quote from one of their IT leaders. We would like to make sure our database isn't overtaxed, show a dashboard with user statistics, allow non-developers in other departments to make mobile apps, and improve security by protecting application secrets. Can you help us do this? So in summary, what we need to do is we need to modernize the architecture. We need to go mobile, enable non-developer employees to create apps, improve management of app secrets, add cognitive search, use serverless API tag, migrate to fully managed SQL database service, and add caching to our solution. This is a high-level architecture of the solution that we are going to implement in this hands-on lab. So now let's get on with the exercise. Exercise 1 is about migrating the on-premise database to a Azure SQL database. So this here is our kind of like simulated on-premise SQL server. So the first thing to do is to connect to it. If we connect to it via RDP, so here's how it looks like when we have successfully connected to the SQL Server 2008 VM. So what we want is to access the SSMS. So this is the SSMS. We want to be connecting to the SQL Server 2008 server. So let's connect to it. Then we want to be bringing up the Contoso insurance database, which is this one. So the next thing we want to do is we want to run some queries. So let's bring up the query box. There's a script that's already written in the repository that we are going to bring in now. Just gonna paste the script over here. As I mentioned, this script is accessible on the documentation in the GitHub repository for this hands-on lab. So yeah, once we have it in this box, we are going to execute it. Right, and that's done. the next thing to do is to restart the server. Yes. Okay, so once that is done, we can then use the Microsoft Data Migration Assistant. So we will use the Data Migration Assistant to detect compatibility issues that may affect the migration from SQL Server to Azure SQL Database. The Migration Assistant also recommends performance and reliability improvements for the target environment as well. Let's get started here. So we create a new assessment. Let's name it assessment. Yeah, so this is correct. So we are migrating from SQL Server to SQL Database. Here's also where we will see the user that we've created in the script earlier come into use. So what we want to check is for database compatibility and feature parity. So with that, click next. Then we add the server we want to check. So the server will be SQL Server 2008 authentication, SQL Server authentication, and the name of the user to use will be workshop user, and I have the password in my clipboard. So we want the encryption connection to be encrypted, and we want to trust the server certificate. So with that, we can now connect and notice that the Contoso Insurance database had been detected. So we want to add it as a source, and yep, now that we've added it, we are ready to start the assessment. So the assessment had detected a couple of unsupported features, which is okay. So let's take a look at the compatibility issues here. So there are no compatibility issues for the migration itself. As for the feature, this couple of feature will probably not. I mean, we've known this earlier that it won't block the migration itself, right? So that's okay. And yeah, so that's it. The assessment is done. So now we are ready to migrate. So let's create a new project, this time for migration. Sorry, there's a little bit of a problem with my keyboard. Yeah, so we create a project to migrate. The source server will be a SQL server. The target server type will be Azure SQL database, which is correct. And the migration scope that we want to choose is schema only. So then we go and create. So for the server name, we have SQL Server 2008. We are using again the credential that we've created. this is both checked as well. So then we connect. So yep, looks okay. Next. So target server will need to obtain it from the portal. So let's head on to the portal to get the target server. To get the database server name, what you want to do is to actually go to the SQL database resource on your portal and yeah, copy copy this name. So we just paste the name here. Again, authentication type, we'll choose SQL Server. We'll use a demo user. This is already created for us via the template. So check both of these and connect. So yeah, connection successful. Then next. So the objects that we want is actually all of this. So we'll generate the script for it. Okay, one thing that we want to check is that there's no selected objects with blocking issues or any other issues. Okay, so here's the schema that will do the trick. We'll just deploy the schema and yep, the deployment results in 23 of these commands being executed and we're done. To do a quick manual validation of the migration of the schema, let's connect to the Azure SQL database that's actually on the cloud. So yeah, so this is the Azure SQL database that's on the cloud. Let's take a look. So yes, we have Contoso Insurance. Yep, and we have those tables that was in the SQL Server 2008 over on the Azure SQL database already. So cool. Now to fully migrate the SQL Server database content onto the Azure SQL database, we will need to obtain the public IP of the SQL Server 2008 VM. So you can use the Cloud Shell for this. Let's use PowerShell. Let's bring it up a bit. So the first thing to do is to create a variable for the resource group that we are dealing with. Hands-on lab. The second thing is to list IP addresses for, okay, let's filter by resource group first. Then, specify the name of the server for which we want the IP address. We want the output to be in table form. And there you go. We have now the IP address. The next thing that we want to do is to obtain the fully qualified domain name of the Azure SQL database server. So to do this, we can again just do SQL server list using the variable that we created earlier. And this is it. After migrating the schema, we can now take a look at migrating the data. For that, we can use the Azure Database Migration Service. So it's loading. We'll create a new migration project. Let's name it Data Migration. So the server and the source server and target server is correct, and activity is correct as well. So we'll create and run activity. The server name, the source server name will be the IP address that we've obtained via the Azure Cloud Shell earlier. So here I'm gonna get the IP address. Authentication type SQL, authentication as usual, and the user will be is connecting to the SQL server, right? So we'll use workshop user that we've created with the script earlier. So we'll check both of these as usual and save. So the next thing will be to define the target server. So we are migrating from SQL Server to Azure SQL Database. So the FQDN will be this we've obtained from Cloud Shell earlier. Same kind of authentication. So the username here will be demo user, which is created via the template. So demo user password. And we want to encrypt as well. So this is the source database and this is the target database, which is correct. So we want to move on. So the tables that we want to involve will be all of the tables. So we'll select all, click save, and the activity that we want to perform is this migration project. So let's give it a name. We'll name it Contoso Data Migration and run. So so once that's done, the migration will be pending, and now it's complete. So it's completed within 7 seconds. Let's take a look at the number of rows that has been migrated. And that's it. So in the next exercise, we look at some of the security benefits that comes with Azure SQL database. So in the first task, we look at SQL data discovery and classification. So that's a feature of advanced data security. And this data discovery and classification tool, it gives you a mean to discover, classify, label, and report sensitive data in your database. So let's go on to the SQL database itself, which is this one. So in the SQL database blade, we'll go to security. So here, then advanced data security. So this is the data discovery and classification tool that was mentioned earlier. So let's click and go into it. So here it says we have found 7 columns with classification recommendations. Let's take a look and see what they are. So if you can see here, there's one column here that has sensitivity label confidential GDPR. So Contoso is concerned about the potential cost of any GDPR violation and would like to label any GDPR field as highly confidential. So we'll update this to highly confidential. To do this, click on Add Classification. We'll find the table People, then column will be date of birth. So we'll change the sensitivity label to highly confidential GDPR. So yeah, once that's done, add classification and save. Now if we go back to the overview tab for data discovery and classification, we can see that DOB is highly confidential GDPR. Right, that's it for task 1. The next task will be about vulnerability assessment. So the SQL Server Vulnerability Assessment Service is a service that provides visibility into your security state, and it includes actionable steps to resolve security issues and enhance your database security. So if we go into vulnerability assessment, then we'll scan. So executing vulnerability assessment scan. So we'll be expecting a couple of failures here when the scan is complete. So the scan is still executing. So yeah, the scan is has been completed. So this tool actually gives you findings of security risk. So these are some of the risks that it has identified. So these are the checks that it has taken and those passes. So let's take a look at some of those that has failed. For example, this high risk one. So you actually get a detailed description of why it has failed this particular check. Then you can take action. So that's it for this part of the task for the exercise. so that you are aware of these features. So in the next task, we look at dynamic data masking. So this feature helps prevent unauthorized access to sensitive data by enabling customers to designate how much of the sensitive data to reveal with minimal impact on the application layer. So let's take a look at what that means. Start by adding a mask. So the schema that we want to choose is obviously this one. We want to do this on people. We want to do this on the DOB column, and let's save. Okay, add, right, and save. So to see DDM in action, we can actually go back to our SQL Server Management Studio. If you look for the Contoso Insurance database that's connected to the Azure SQL database on the cloud, and do a new query. So this snippet is actually from the task itself. So we'll execute this query. So to create a DOM user, a DDM user, sorry. So with that, we can now run another query to observe the result. So this is the other query that's actually in the task. So execute. So if you notice here, the DOB field is masked to 1900. For comparison, we will run another query in a new query window. We will select, oops, sorry, something with my remote desktop again. Select top 100 from okay. So if we run this query, yeah, so this is the unmasked version. Yeah, so that's it for this exercise. Thank you. The next exercise will be about Key Vault. Remember earlier, Contoso has requested that the application secrets are to be stored in a secure manner. So here's how we are going to do it. Let's go to Key Vault. So we're going to add a access policy. So we should go to access policies and add an access policy. We will not do this from a template. We'll leave key permissions as 0. We'll leave secret permissions to all. We want to govern all of this. Certificate permissions will be, we'll just leave it as 0. And authorized application is non-selected, which is okay. So for this, please click this and select your user. I'll select my own user identity, but I will not click this now so that I don't expose my organization's directory in this video. Once you're done, click on add and then save. So this is there, and that's it for this task. So in the next task, we add a secret to Key Vault containing the connection string for the Contoso Insurance Azure SQL database. So let's go to that database. So this is that database. Then we'll get the connection string, which is this. So we'll copy everything. Then we go, we'll need to store this somewhere. So yeah, I choose Notepad, and here I replace that password with my password. So this is the password in the exercise. So yeah, so once that's done, you have to copy this and place it in Key Vault. So click here to get to Key Vault, and secrets, which is here. Click a new one. Have a manual secret. Name it SQL connection string. Paste from Notepad. And yeah, these options are okay. So we'll click create. And that's all there is to that task. So the next task is about creating a service principal. So I've created this service principal, but I'm not going to show it on video as it will expose some of my my tenant ID specifically actually. So if you follow these steps, you will get to a service principal. So the next step is about assigning the service principal access to Key Vault. So first we list the Key Vault. So this gives you the name of the Key Vault that's actually within the resource group. Then we set policy. Yep, so now you can see that the permission had been given to get and list secrets for the service principal app. So for the next exercise, we'll need to connect to the lab VM. So this exercise is about deploying web API into Azure App Services. So as usual, we get the RDP by means of the portal. Okay, so now we have the RDP, and I'm going to connect to the VM. So here we are in the VM. So what we're going to do is we are going to open the starter solution in Visual Studio. So let's close this. So the solution is actually in here. Let's close this off. Oh my. Okay, maximize this. Let's get to this. Should be a C drive here. Yep. MCW. Hands-on lab. Lab files. Yeah, there we go. So we'll open this with Visual Studio 2019. So this is going to take a bit of time. So I'm gonna sign in. to FA. And we should be in soon. So let's update the web API to use Key Vault. So expand the web API, look for program.cs. Okay, so here we'll need to work on this to do. Insert code to this block to create a connection to Azure Key Vault. So let's get the snippets from the documentation. So pasting the snippet in, we get this to add Azure Key Vault to the create web host builder function. Next, we'll need to work on startup. So let's get that snippet again for to do number 2 over here. So next in startup.cs, we add a line to allow the application to retrieve the connection string from Key Vault using the secret name. Now, before deploying the web API to Azure, you need to add the required application settings into the configuration for the Azure API app. So in this task, you use the advanced configuration editor in API app to add in the configuration settings. So let's go to the app service. Not this, yeah, this one. Okay, so this is the API web service. So click on configuration, then advanced edit. So we'll need to add a few parameters here. Let's get this from the documentation. So here's the snippet. We've filled in the values with the values that was created earlier. So this is the name of the Key Vault. This is the service principal application ID, and this is the service principal password. So once that's done, click OK and save. So the next thing to do is to deploy the API to Azure. So now we are ready to publish the API changes to Azure. So we get to this dialog by right-clicking here and choosing Publish. And here I've already chosen to publish to Azure App Service, to this subscription, and then to now this specific app service. So then click on Finish. Now we are ready to publish. Just click on Publish, and off we go. So this should take a little bit of time, and so once publishing is successful, we should be able to visit the API. So let's copy this and paste it into our browser. So we don't technically visit the API, but you know what I mean. If we go to the Swagger of the API, we will be able to see that it's now available. We can test the functionality by trying it out. If you look at dependence, click on try it out and execute. There you go. So this means that the connection to the Azure Key Vault secret is functional. Next, we add the API app URL to the web app settings. So to do this, we again use Azure Cloud Shell. We list the web apps that are available within the hands-on lab resource group. Again, we want to see it in the table. So we want to get to this name. Okay. So with this, we want to replace this in our Cloud Shell command. So when we obtain the web app name, we use it for this variable here, coupled with the default host name, which is the API. We then set the web app config for API URL as this. Now, similar to the API, we publish the web app itself to Azure. So hands-on lab web. Finish. And publish. So this will take a bit of time. And we shall be back once this is successful. Okay, now that the publishing is successful, we get the URL of the website and access it via our browser. So here we are accessing the Contoso Policy Connect web app via the browser. So there we have it. If we click on Manage Policy Holders, the data should be loading from Azure SQL database. That's it. So if we access the web app via the browser, we will be presented with this page. So this is the Policy Connect web app. If we log in, let me get the password again. Yeah, should be correct. Yes. And if we click on, so this is Policy Connect, right? So this is the Policy Connect that lives on Azure now, and it's connecting to the API that's actually on App Service. So the App Service then accesses the secret to connect to the database from Key Vault, and now we are accessing the policyholder table. So these are the data that's actually on from Azure SQL database. So if we click on any of this is all good, right? I mean, we've just migrated to the cloud with quite minimal effort. But if we click on these details here, and if you look at this file path, this is still a network file share. So we want to bring things even further by actually changing this to blob storage. And that's what the next exercise is about. If we go back to our resource group, hands-on lab, and if we go to the storage account, so we'll need to add a new container. So let's call this container policies. Okay. So if we click on policies and properties, we should get the URL of the storage container. To copy existing policies from on-premise storage to this container, we'll need to get the access key. So we can do that here. And we just copy this before we move on to the next task. Within the storage account, there is this section called the shared access signature. You should click on generate SAS and connection string to generate a SAS token. Copy it to clipboard so that we can use it later in the functions exercise. For task 3, let's go back to our VM, the lab VM. And the first thing to do is to download azcopy. So it can be downloaded from aka.ms/download azcopy. So we'll have to install azcopy. So with azcopy installed, we can then go to the command prompt and enter the following. So first, let's go to where azcopy is installed. So it's installed in program. Um, yep. So we will then need to issue this command. So all this is you're telling azcopy to get from this source, which is a directory on this computer, on this VM, and copy it to the destination, which is the blob storage container that we've set up on the cloud. And here's the key. So with that, let's issue the command. Yeah, so there's about 650 files in there, so let's wait for a little bit. When transfer is successful, this is what you will see. 650 files transferred successfully. It took about 11 seconds for the transfer to happen. And we can verify this by going to the container blade on the portal. So as you can see, the policies are already here in the policies container that we've created. The next thing to do is to modify the API to enable users to access their policies document here from Azure Storage account. So we'll make use of Azure function to do this. Let's turn on the Cloud Shell again. Okay, make this. So let's take a look at the function app that we have. So hands on lab. So this is the function app. Let's start with a couple of variables. Function app name. Have the storage URL in here as well. So storage URL, and we'll have the SAS token that we've created. So the next thing, we'll use the CLI to configure the app settings for the function app. So az function app config app settings set. So we want to apply this to the function app name, and which is within the hands on lab resource group. So the settings will be policy storage URL equals storage URL and policy storage what do we want to call it, SAS equals storage SAS. Okay, so let's run this. Cool. So we've configured this. Now we'll need to go back to Visual Studio to modify the function app. In this task, we add the SAS token and the container URL locally for debugging purposes. So if we right click on function app, then look for properties. So then go to debug, and in environment variables, we'll add policy storage SAS. Okay, the value of this will be the SAS that we've obtained. Then we add another one for policy storage URL, which is this. Okay, so moving on, we can now create an Azure function in Visual Studio. So here's the code of the function that we are creating. Two things to note here. The first one is the route. So we've added this route here to accept a policy holder parameter and a policy number. The next thing to note is we are actually using this to then obtain the file from storage. So here's where we specify the container URI to use and the SAS token that enables function to access the storage container and the blobs on the storage container. Also note here that we are actually using the environment variable to get those values in. We can debug these functions locally. Okay, let's try this. And so what we want is to get a local version of the function running. So the first time we run this, we'll need to download the CLI tools. Yep, we are waiting for a lightning, the symbol of the functions service. So notice here that the memory consumption and the CPU consumption is shown to you from within Visual Studio as well. So here's the function environment starting up. Okay, so now that we have the functions loaded, we'll need to get this URL. So calling this function will get us the storage, the policy from storage. So we're just going to replace this parameter here with a Versito just for the sake of testing, and this as the policy number. So if we place this URL into a browser, we will be able to then see the policy. We can now publish this function to Azure. So let's stop the local instance from running and click on publish. So we choose Azure, hands-on lab, consumption. Yep. Then just click on publish and off we go. Yep, here's the output while the function app is being loaded onto Azure. And we've successful. We are successful. So the next thing to do is to enable application insights. And for this, we have to go back to the Azure portal. Well, applications insights isn't actually necessary for the delivery of the policy retrieval service. It is a good mechanism to enable to help us monitor the health of the service itself, and also to help us gain insights into how the application is doing against actual user requests. So to turn it on, we can actually do so via the app service itself. So this is the app service. So if you click here, we can turn on application insights. So we'll create a new resource name. This resource name is okay. We'll just click apply. And that's it. So application insights is now turned on. So we'll just, there's a bunch of metrics that is gathering already, but for now, before we move on to the next task, we'll just turn to this live metrics here and leave it for now. And we'll move on to the next task. So the next task is to add the function app URL to the web app application settings. As we've done this before, I'm just going to walk through this very quickly. So again, we are using Cloud Shell to do this. So we first get the name of the web app. Then we also get the default host name of the function app. So placing this in variables, and we have to obviously define the web app. So we use the same config app settings to set the function app URL. So here we are saying documents path, policy documents path to use the functions app. Okay. This default host key is obtained from the functions apps itself. If you click on app keys, this gives you the default host key. Okay. So doing that, you should arrive here. So once the function app to retrieve the policy from blob storage has been set up, you can now go to policy holders and then go on to details to retrieve the policy document. So if you recall earlier, we used live metrics to get the telemetry of activities that's happening with the functions app. So here we do see that, upon request of the policy document, the logs here will show that the document had been requested. So if we look into one of these, we can actually see details of the activities that occurred. Now, do note that this telemetry here is live, so you will need to keep this blade open while the policies are being accessed for these logs to show up here. So one of the desire of Contoso is to make use of the documents that are actually stored in their storage account. They want to make it searchable. So previously they were not able to search it, so now they want to make use of, since they're on the cloud, Azure Cognitive Search Service to go through the documents to create an index so that the content of it can be searched. So we do this by adding Azure Cognitive Search to this storage over here. So this is actually in over here. So we add Azure Search. So we select this. So data source name, we'll name it policy docs. So we want to extract content and metadata. So passing mode default connection string is already there. So the container name will be policies, which is the container that we store all of our policies. Then next. So one thing that we will need to add is this one here. Okay, so we'll need to add this particular cognitive service. This has been turned on earlier with the template, and we also need to add an enrichment. So here we can keep it as this name. So these are the skills that we can add. So we want to extract people names, extract organization names, extract location names, extract key phrases, and to detect language. So next. So here's where we may want to name it as policy docs index. So we want to make actually all of this retrievable and all of this searchable. Okay, then move on. So yep, once we're done, click on submit, and off we go. So once we've created a search index, we can then take a look at the additional fields that have been added by cognitive service. So yeah, so this success is indicative of the current state of the indexer. So we ran it about some minutes ago, and there's 650 documents successfully indexed. So if we go through search results, we should now be able to see the additional fields that cognitive service had added. So there should be, yeah, so if you look at this, these are the things that requires special attention, right? So these are the fields that cognitive skills has added. So we specified earlier people, orgs, locations, key phrases, yeah, things like that, languages. So yeah, so if you notice here, there will be some, yeah, for example, this one with people added. So cognitive service had identified that Nolani Frederick is a person, and it's, so when we search for Nolani Frederick, then we are now able to find this person from this search result. So we can also search, using other kinds of field, like key phrases, yeah, things like that. So this improves search quality. Here we have organizations, yeah, two names. Yeah, so that's indexing and cognitive search indexing for you. So in this next exercise, we look at adding our API app and the function app API into API management service. So before we proceed, it's easy to add an API to API management service if we have the open API specification. So we do have one for our app API. So if you go on to the app API, then go to the URL here. So add Swagger to, yeah, so this is the Swagger of our API app. So if we copy the link here, so this is the open API specification. So with this available, we can now go on to create, add this API app into API management service. So APIs, open API. So we want full. So add the link over here. So we only want to do this for HTTPS. So this had been filled from this link, and yeah, we want this to be unlimited. Okay, that's it. Great. So after we have added the Policy Connect API to API management, we will need to cater for cross-origin resource sharing support. So if you look at the host of the web app, this is how it looks like. It's on azurewebsites.net. And if you look at the host for the API management, so this is the gateway URL. So azureapi.net. So there is a cross origin, right? So what we need to do is we go to APIs, Policy Connect, edit the policy, and add this chunk of code here to allow this origin to access the API. So more documentation is available here. To complete adding our API app and configuring it in API management, we need to go to settings, need to copy the URL of our API and add it to web service URL and save. So that's it for the API, the app API. So let's look at the functions app API next. Adding a function app to API management is a little bit easier. So if we add API and choose function app, can then browse and look for the function. So we want policy docs, select and create. And that's it. So now that we have an API management interface, we want the app itself to actually go through the APIM instance instead of going to the functions app or even the API app. So what we need to do is we need to reconfigure the policy docs path to utilize APIM. So to do this, we go back to our old friend Azure Cloud Shell again. So I've done some setting up because we've done this plenty of times. So one thing that I've added is APIM URL. So this APIM URL is actually the gateway URL that you can see from the API management service overview. Okay, so this is the gateway URL. So if you plonk that over here, so the next thing to get is the key to the API management service instance. So this can actually be obtained easily via the developer portal, but this is currently disabled for now. But you can actually still access this via the portal overview. So if you click onto portal overview, here you go. That's the developer portal, the legacy version, right? So if you go on to administrator profile, you will be able to get the key that is necessary to access the API management service instance. Here we copy the key and put it here. Right. Lastly, we need to define the new policy docs path. Okay. So for this, we can actually get it from the developer portal. So this is actually in APIs. So the related API that we want to change is the functions API that retrieves the policy documents. So this is the one. Yeah. So this is the new request URL. Notice the parameters are still here. So if you get that and plonk it over here, we can now then set the new settings. So let me get that line. So here's that line. And we're done. So the web app will now will now go through APIM. And that's it. So to test out the new endpoint, which goes through API management service, we do a refresh over here. So as you can see here, policy holders is actually requested from this API endpoint, which has APIM in it. So this is our API management gateway URL endpoint. And that's it. The last exercise is about creating an app in Powerapps. That's one of Contoso's interests. So let's set about doing that. The first thing to do is to create a new SQL connection. We can do so by clicking here. And choosing SQL Server Authentication. Okay, so we are connecting directly. The server name to use is the SQL database host name that we've created earlier. The database name will be Contoso Insurance. Okay, and that's it. That's how easy it is to connect to a SQL Server database from Powerapps. Right, cool. So as we want to create an app to access policies, we click on the policies table and then click on connect. So here is where we can design the look of the web app. So first thing, we want to change this to policies. Then we want to design the detail screen as well. So let's click on detail. And we want to then also change this. So we want the order of this to be in the order of name, description, default deductible, and default out of pocket. So what we do is we hover over the card here and drag it. Okay, so this one should be the third one. and we want to drag name to be the first position and description to the second position, default. And then, yep, oops. Yep, so default, sorry, this should be the third one. Yeah, so this is the order that we want. We also want to make this a little friendlier. So default out of pocket max and default deductible. Okay, let's change this to policies. Policy, sorry. This is a single policy. Yep. So lastly, we want to save this app and run it. So file, let's give it a name, policy connect plus, and save. Okay, so now let's go and run this app. Cool. So we are able to browse the policies that are available. Also, there's a minor typo over there. So let's go back and correct this. Policies. And then run it again. Cool. So yeah, that's it. That's how to connect a Power App to the database. So after going through all of the exercises, you may want to delete all of the resources that are involved in the exercises. So that's the easy part. So all you need to do is just click on this button on the resource group, type in the name of the resource group again for confirmation, and press delete, and all of the resources will be removed. So the other thing that you may want to remove is the app registration, the service principal. So go to the app registration for Contoso Apps V and delete this, and that's it.